Good afternoon, ladies and gentlemen. Excuse our tardy start here. We're a little bit late, but the topic we're going to discuss today, the Executive Roundtable AI Robotics, the Competitive Booster. I have prepared a long introduction here, but we're going to save the 10 minutes and we're going to get right into the discussion with my expert speakers here. We have, got to see the order here, we've got Wendy Tan White here, CEO of Intrinsic, directly to my right. Then we have Francesco Nori, Director of Google DeepMind. Then we have, Mark Tierman, Chief Strategy Officer of Boston Dynamics. Lorenzo Macia, Professor of Intelligent Biorobotic Systems and Director of the Munich Institute of Robotics and Machine Intelligence. And then we have Corina Apicit, who's the Head of Artificial Intelligence at Continental Automotive Technologies. My name is Ken Fuhi. I'm Editor-in-Chief of VDI Nachrichten, German analog and digital newspaper. And we've also got Spot here, who is not quite up to speed on AI robotics and able to take part in the discussion today. So I think I'll ask Spot to leave the stage now. If he'd just be careful that he doesn't step on my feet while he's leaving. Okay. Before we get into the discussion of AI robotics as a competitive booster, I think it's important that we also look back, reflect on how far we've already come with the AI journey so far. Maybe for all of you, you can decide who answers what and pick it up from one another. What are the major milestones that we've achieved up to now in AI and robotics?
I could probably kick off. Are the mics on? Yep. Okay, cool. Maybe I'll start. We came out of Alphabet as a separate company 4 years ago, and in that time, one of the biggest step changes I think has been obviously in the change in sensors, compute, and a collection of data. But actually, probably the biggest one is AI. I think you all know that's become a really front and center. And it was the ability to collect that data, but now the ability to process it with transformers, then LLMs, and deep reinforcement learning. That's actually really changed the ability for robotics to be much more flexible and to adapt in real time. And I think what we've looked at doing with Intrinsic is really trying to bring that tooling and ability for you to actually put into practice in real deployments. I think that's fundamentally changed. When we were here at Automatica 2 years ago, we were talking about that theoretically as a platform, and now we're talking about actually having real customers building with those platforms and being able to use AI skills with their robotics. I think that's fundamentally changed in the last 2 years.
I'd love to jump in with lots of questions on that, but we'll go around to see if...
So, I can? Okay. So, I mean, for sure, I totally agree with you. On our side, what we are trying to do, how to use this big wave that is rising on AI at Munich Institute for Robotics and Machine Intelligence is try to go into the creation of robotics factories. So investing in large infrastructure where you can test different robotic systems, create foundation models, and then give to this foundation model generalizability in order to be able to, let's say, interpret all the needs that come from industry. And this is the main idea that we have in mind. We have started with what is called KI-Fabrik, Künstliche Intelligenzfabrik, that is actually under the Deutsches Museum, is an infrastructure of about 100 robots that work collectively in order to extract data and create this collective learning or foundation model. So for me, of course, there's this rise with the transformers of the way of AI. The main problem is generalizability and create this large data set that should be used for training models.
I, of course, agree with the previous 2 points that were made, especially Wendy, since she's also part of Alphabet. So definitely we're aligned in many things. I personally like the fact that finally we have a new tool, and this new tool allows us to instruct machines to do things by using very natural interfaces, which is natural language. I had fun with language models. Nowadays, I'm having fun by combining language models with robotics, like instructing a robot with natural language. I think this is very powerful. Of course, it's at the very beginning, so we need to further develop the technology, but we are really in a good place. This is really exciting for me as a research scientist, but also for applications like the ones we see here at Automatica in these days.
So for me, the biggest achievements with artificial intelligence from personal perspective is Deep Blue. So back in 1997, the smartest things which a human being could make is to win in chess. And having a program beating the world champion in chess, it was amazing. The second one is definitely ChatGPT moment, making a powerful AI solution available to everybody who has access to internet. And from professional perspective, as executive in automotive industry, I would mention the achievements in automated driving beginning at 1980s in Germany. So I think we have enough inspiring achievements and motivating achievements in order to build upon and continue this journey.
Yeah, I think it's true for sure that AI has transformed our company over the last couple of quarters dramatically. And since Spot was on stage here, one good example is that these robots all of a sudden have a semantic understanding of their environment. So when 2 years ago Spot saw the world as obstacles, Spot now sees the world with more of a semantic understanding. So he recognizes humans as humans and behaves a little bit differently. But when we do industrial inspection in a facility, you can now also ask the robot anything and say, hey, did you see any grain on the floor? Did you see any air leaks? And with a very natural language interface, you can ask the robot anything, and the robot can go back through all its memory and say, okay, this is what I saw today. So that sort of semantic understanding of the world is what really gives us another breakthrough in capabilities.
Yeah, I think where you introduced it, Wendy, 2 years ago, we talked about a lot of theoretical things, and since then, your example now shows that it's become reality. But how do we get from, how do the application industries get from where they are today to robust and generalizable AI systems? So how do they put this into place?
I think we very much went through that journey. I mean, to be honest, I think a lot of you know, we started in Google's Moonshot factory, which was, we were really fundamentally doing a lot of R&D work, and actually with Torsten Kroger, who's our chief science officer at the time. I think I've gone on a journey with both Torsten and actually our CTO, Brian Gerke, who a lot of you would know from Open Robotics as well, who's been very pragmatic about getting applications out in the real world. It's very different going from your research models to true putting it into application, to actually then putting it into production, and then operating it in reality. And I think that's what this audience we're talking to here is what you're actually worrying about. How do you take that and apply it in reality? And I think what we've definitely tried to do is intrinsic, but also with the whole ecosystem. And that means a lot of the folk here, whether it's academia, whether it's DeepMind and the model breakthroughs, whether it's industry, how do we help you take each of these building block components? So AI skills, different hardware assets, actually integrate them and apply them in a workflow process that is actually valuable to you as an end customer, and actually deploy it. And so a lot of what we've actually had to do is get that pipeline right, and to make sure we future-proof it so that as the new models come, whether they are specialized models, which are very practical for you today, like, I don't know, grasping, let's say, or perception, or we actually eventually get to true end-to-end learning and more generalized intelligence, we want to be able to make sure you can wrap that and add that to the workflow you need to do to put it into production. And I think that's the big step change that's happened here. And I think that's the step change of this whole industry, is actually moving, really integrating that hardware and software pipeline properly.
Can I follow up?
Yeah.
I think I agree, absolutely. We need to do it collectively, together. I think that's the key word that I want to highlight. As a matter of fact, I think I'm a research scientist. We do a lot of basic science, but we had to ask Wendy and Boston Dynamics as well to start testing our technology. And I think this is like a good image of the fact that any technology requires collective work together to make it suitable for applications, to make it suitable for different companies, to understand what is useful for, also to make it such that it's not harming the society. That's another important bit. I think all of this collaboration needs to happen with academia, as Wendy was saying. There's really a need to do it collectively rather than having a single owner of the technology and deploying it. I think that's a must-have, and the fact that nowadays we have so much, venture capitalists trying to fund the different projects is also a good sign that we can do it even more collectively. The society, the whole society wants this to happen, and this is, I think, a great opportunity for us to do it with more people involved and not doing it siloed, but just to share the journey together and get it done all together.
Yeah, talking about sharing the journey together, I think what's so important with what both of you said is that from the commercial side, companies need to start today, because you cannot wait for 99.9% reliability on mobile robots or our AI models and say, oh, I'm just going to wait and let my competition do the work first. No, you need to start today. And I'm always surprised how much hesitation we're getting in Germany for new technology adoption. That's not the case in Asia, and it's not the case in the United States.
Do you want to?
Well, for me, now I would say, let's say a word, and everyone will say, oh my gosh, I mean, there should be a certain certification agency for all this model that has been developed. Because we have, different layer of security, and this layer of security cannot be only taken by the foundation model, but should be an intrinsic layer of security at the foundation model with the certification. There should be another one that relies on classic control. There should be another one that relies on embedding a certain intelligence into the mechanical structure. So if you have this 3 layer of security coordinated and certified, then probably this technology is going to be accepted. I understand. I mean, it's a lot of bureaucracy behind, but we're always talking about, in this case, I mean, certain application, especially for what we do, collaborative robotics. And when you put the human in the loop, it should be super safe in if there are 3 different levels of security. That's the idea.
We'll come to the human in the loop in a second. But you've described coming from academia to the first level, which most of you are on here. But I'm looking at all the people out here who are the visitors, who are the people in industry here. How are they supposed to adopt what you're offering to them?
Maybe I could give an example.
Yeah.
Can I give a real example? In fact, you see it running in I'm going to punt our intrinsic booth, if you want to see there. There's an example of a cell with Martin Systems, who are a CNC machine builder. And what we've actually managed to do is to take their CNC machines and add a machine tending application around it using robotics with AI. Yeah, so in effect, the system can actually look at different, let's say blocks of metal that can be CNC'd. It can actually adapt and pick the parts, even if that configuration changes, and actually put it into the machine tending. But the key thing about it is it can adapt to the environment, so it can effectively perceive, and it can adjust its grasp in what it's doing. And that was built using our product called Flow State, where you could add those AI skills in, add the assets of the CNC machining and then the robots, run that in simulation, and then deploy it in real time. So we tried to make that pipeline actually work. And the end application that's produced can be used by an operator and a manager in, let's say, a factory outlet, without knowing how the AI got added or how the assets got added in. And that's making it practical for people to use and get the value out of it. Yeah. But you can go and see it. It's actually working in the booth.
Coming back to what Lorenzo said there, where's this certification body going to come from? Who's going to do that?
Well, I mean, every country has a certification. We have the TÜV, actually, TÜV, but it should be something, for example, centralized. Eventually, I mean, America has American Association of Robotics. Europe can have European Association of Robotics. They should converge. I mean, this is quite a big question. I don't know how to reply, to be honest, also because I'm not aware of all the certification entities that are around the world, especially for what concerns industrial robotics.
Can I perhaps go back to the journey I was describing?
Yeah.
I picture this journey of certification as well as something very collaborative. These days, the technology is very new and green, and I think a top-down kind of approach will never work. It has to be done on the field with people really working with the application of the technology. Otherwise, we risk of creating too many boundaries before they are actually understood enough. And I'm very aware this is very powerful technology and it's very disruptive, but at the same time, I need to think balance with the idea that needs to come at the right time, with the right limits and the guardrails that are needed only when the technology is really understood a bit better.
But are we worried that Germany remains competitive, its competitive advantage in the world? Are the Chinese creating certification agencies, or are they just doing?
They're just doing.
I think that's the risk, is that we're in a globally competitive world. You won't get to control it within just Europe or within America. I don't know, what I'd love to know from the group is maybe when you look at something like self-driving, for example, which is probably our best example of actually putting really a robotics verticalized application with intelligence into the world. How do we go around that? And the greatest fear I know from talking to customers here is that with the traditional certification, everybody understands literally step by step, detail by detail, inside the process, whether it's safe or not. The problem with end-to-end learning, for example, is that it's a black box. You can't see inside, so there's a fear. But it might be mentally, we need to shift that to look at, okay, what about, how do we actually validate the boundaries of the outcome versus worry about the detail of inside exactly what's going on? Now, why would I say that? We all work as human beings today in many dangerous situations, and how do we certify that? Yeah, we look at the outcome and the process we create, and can you get to a 5 nines level of accuracy with that? And so, is there a different way to look at certification? I'd ask.
It's based on experience, if you're concerned about human, but then reconnect to what data are we using for training. So it's impossible to foresee any possible situation, but I suppose that certification should start also from the data that are fed during the training, and see if you can embrace a certain percentage of situation that are the optimal one, the unoptimal one, and the dangerous one. I believe, if I understood that if you see, this, let's say AI as a black box and you cannot really look inside, but at least we can start with the boundary condition, with what we feed to the model.
Yes, I think that's right.
Yes.
Yeah.
This is, I don't know if aligns with your...
It does. I think the boundary models may be the way to look at it rather than,
But the way I think about certification is a layered approach. I think that at the moment we already have a good level of certification for the technology that exists, like cobots clearly use the technology we're describing. There is human awareness with cameras, with different kind of sensors. Now we're adding a layer. I go back to Mark, because I think Mark made a very good point at the beginning, which is like the semantic understanding, completely new thing. We didn't know how to do it. All of a sudden, we know how to do it, right? So this new layer is a semantic layer. Like, you can instruct a robot with natural language, but you should also avoid to instruct it in the wrong way, pick up a gun and shoot at someone, for example, right? And that's a semantic understanding. It's not about the pick and place capability. The skill is already there. It knows how to do it, but you need to put this layer of semantic safety. And that's why, honestly, this opens the door to a comment that is very corporate, but we work on a thing like this. We really have a constitution, we call it. It's an extension, it's a benchmark, it's a public benchmark you can adopt yourself for your language models, which sits on top of the semantic layer and basically gives the constitution that it needs to be followed in order to execute tasks. You can look at it as a sort of extension of the Asimov's law for safety in robotics. So it's not 3 laws in this case. It's like, I think, 258 or something. It's like a big constitution of laws. But to your point, semantic safety is a new layer on top of the many other layers that we already have, which is very new to this technology.
I have about 10 other questions for this, but we got to get on to
Sorry,
the
I know
next
this
area.
is gonna
Barry.
come.
Let me pull it back a little bit. How will AI robots overall influence the world of work in factories on a more global level now, coming away from the models?
I think there's been a fundamental shift. To be honest, it happened through COVID and beyond, where, you know, I'll give you an example in the US. Even 2 or 3 years ago, there was not enough skilled labor in the US to bring manufacturing back to the US. And so now there's a big, as we all know, there's some big political drives to bring a lot of manufacturing back to Europe and back to the US. How are you going to solve that demand problem? And the only way, literally, is going to be through automation and robotics. And so I think the imperative has shifted from one of fear in that, particularly in the industrial space at the moment, from fear to one of actually there is no other solution, actually. And I think that change in customer demand and even adoption from a country perspective is actually changing the dynamic very significantly. So, you know, one of the things I saw going around factories just after COVID was there are jobs that human beings really just don't want to do anymore. You know, when you're walking around an automotive factory and you watch somebody putting in an ABS braking system underneath a car every 5 minutes, who's being paid extra because everybody knows eventually they will have a fundamental back problem, that's not okay. You know, when you see chickens being deboned in, you know, for production of, you know, cheaper chicken during COVID, and there's a lot of human beings doing that work, they don't want to do that work anymore. That's just some basic jobs. But just to do the production GDP that we're all looking for still, without the human beings to do those roles, we're going to have to find a way to solve that. And I think I'm talking about that industrial. I think the jobs a lot of people worry about now are things like, have we decimated the media industry because of you know, production of videos? But at some point, it's going to be about, it's the fundamental tasks that we don't have enough people to do that are going to be solved.
Yeah. So manufacturing has certain advantages. First, the processes, the rules are somehow known, so they are suitable to be automized. Second, the people working in plants, they are educated. They will maybe rather respect certain rules in the interaction with robots than the normal humans would be. And the third advantage is the work is very hard. So we shall release humans of doing this kind of hard work. And despite of having these advantages in manufacturing, the automation degree in automotive industry is at most 40%. So we are not at a status quo where everything what can be automated has been already automated. I can give you an example from Continental where we do not assembly vehicles with robots, but rather do visual inspection through artificial intelligence. And of course, we release the humans of a routine work, which is very, how should I say, not so human, I would say, to stay for hours along the production line and see if certain errors occurred or not. How the automation will change the work, hopefully for the better, releasing humans for the direct, immediate work, but somehow enforcing us to take the role of teaching robots, further developing robots, and developing new AI solutions to do the work which previously was done by us.
Lorenzo?
So I can continue smoothly on the line that you just opened. So for me, one of the biggest revolution can be in this way, large language model. Because right now, if you have to hire someone that is able really to, let's say, install automation line, optimize it, you need someone with skills that are rare to find. The advent of large language model allows to have people, for example, that are able to prototype faster, or having at least the first layer of prototypization, and then eventually there should be another layer of optimization. But it makes everything by far much faster. So I suppose that they will be born probably in the near future, very near future, people that are really able to set up a production line in a much faster way. And this might be, thanks to the large language model, a capacity open to many different people rather than before, in which the very skilled programmer were only able to do that.
Yeah, but I think that brings up the fundamental question is, like how transparent and explainable must these AI decisions in robots be in order for the humans to accept them? If there's only 5 people can program, then the 500 in the factory are not really going to accept that, are they?
I'll take this one. I wanted to reply, how do I see the future of automation in a slightly different way? With a personal experience. I'll start with my experience with Workstation, installing a OS, or operative system. I remember when I was a PhD and I was like, okay, I'll start with Linux. And it was like, of course, like the very geek choice, and then it was like a pain to install. And all the drivers, you need to recompile the kernel, and then it was like really an experience. And I had joy in it, like I was really enjoying it. It feels like I'm achieving something, but it took a long, long while, and it was very, very difficult, and it was a pain to maintain, right? And I also, all of a sudden, I said, okay, I give it a try to the Mac experience, you know? And I was like, oh my God, this is like heaven now. Everything works. Everything really, really works out of the box. I don't know what's happening under the hood, but really, really, it feels better. I feel like I do what I need to do. It works much better. And it's the same with cell phones now, right? You buy a cell phone, any brand, Android included. It's like the experience of using it is very smooth. Now, automation, I think, should be the same. Like, automation should be as easy. And maybe I don't know what's under the hood. Like, I played with humanoid robotics for like 10 years in my life. I was at the Italian Institute of Technology before Google DeMind. I was developing a humanoid. It was a pain. It was a joyful pain, yes, but it was really a pain to automate, to write a single behavior, to do a demo for Automatica. I've been here. Angela Merkel visited our booth once back then, and it was a pain to prepare it. I just want this pain not to be anymore there. Like, natural language points in that direction, trustworthy, maybe another, yes, sure, I need to trust what's happening, but it needs to be a pleasant experience rather than a pain, which is like kind of a second type of fun.
It's me? Yeah, super. So, how transparent shall AI and robots be? It depends. It depends. It depends on the application. We probably all use ChatGPT-like solutions. How many of us understand how these systems were trained, how they function, and does it really matter to us just to translate something or whatever? I don't think so. But when it comes to self-driving, to automated driving, of course we have to develop explainable AI methods in order to make this technology certifiable, approved, homologated, and for hopefully unexpected case of accidents to understand why the accident happened. So clearly it depends. It depends also on the wishes and the preferences of the user. Yeah.
I think, but maybe just touching on the user point, because I think this is what you're also saying, Francesco. The world tends to adopt things because it adds value and because it's easy to use. Whatever the certification is, actually, ultimately, the certification can actually it's there for insurance certification and to protect. And so you'll find some industries and some countries and some applications will take a different view, which is as long as people want it and use it, and it's within a certain boundary of risk, we can take that risk. So I think there's some balancing that has to happen here around, it's to your point, which industries really need that certification because the risk is too high versus ones where we need to keep innovating. Because otherwise, we will get out-competed is the other problem. Yeah? And users will go where they want to use things.
As Boston Dynamics, we're very close to you being able to interact with Spot with with natural language, and the same will be true for humanoids. Now, there's a little bit of a humanoid craze at the moment on the internet, especially. So, are they coming tomorrow? Probably not. But are there going to be humanoids deployed in the next 10 years? For sure. So, I think it's on that journey that folks like DeepMind are working on making sure that we can teach these robots by showing them, right? Hey, robot, let me teach you how to do this task, and then the robot can repeat it. And I think that will become a very natural process, and that's around the corner.
So, I mean, let me reconnect on what basically everyone is saying. In my opinion, to have something that is really reliable, and then at the end, it's us programming the system, feeding the data, we have to start from the education of the person. So what is the main question right now with AI? How does the educational system will change? a good programmer or a good designer is someone that has studied C++, I don't want to say Fortran, but really, the low-level code, and then eventually use AI to speed up 100 times. But you cannot rely on people that don't know the basics and use AI just to save time. Duolingo, for example. I'm studying German because I live in Germany, but my German is schlecht a bit, ein bisschen, let's say. So Duolingo doesn't give you any rule. You just learn because you repeat so many times your mistakes that at the end, statistically, you say, okay, now this time is correct. This is what is missing. It's like giving a computer-aided design, that is the instrument without AI, to someone that never studied mechanical engineering or mechanical design. And this is exactly the same things. So we need to have still someone that is trained since the beginning at the university, because we are the one, willing or not willing, that try to form the intelligentsia of a country, that knows exactly the basics, and then after that use the layer of AI just to speed up 100 per. And then probably you will have something that is by far safer because it's administered by someone that knows the roots.
I have a nice follow-up on this one. I want to just sort of address the black box. Oh my God, is black magic inside? Also following on what Lorenzo was saying. It's not completely black box. I want to, I worked at DeepMind long enough to have seen that there are techniques that are just different from the classical Lyapunov theory of stability that I used when I was like a control theory guy back 10 years ago. So it's not a safety certificate as we used to have in the classical automation sense. Nowadays, it's a different thing, but we can look inside the black box. We can understand what kind of information is in there, what kind of safety you can guarantee. It's just that it's extremely numerical, and again, you used to use another neural network to understand what's inside in terms of information. So I don't think we are completely moving in the dark when it comes to safety of an AI model. We just need to have and adapt and develop new techniques to the new use case, and also target what we need to guarantee in terms of safety in a specific way. So it's slightly changed. There's more work to do. I think certification is a very good topic to bring up, but we're not completely in the dark at all. There are techniques. People are really interested in certifying neural networks as well to guarantee boundaries of working properties. So I think that is not as black box, because otherwise people, the general public, will believe that we completely are in the dark and we just magically put data in and get outputs out. This is not what it is. We do a lot of safety guarantees and we understand what's inside, which is a good news for the society and the use of these models.
Just following again from Lorenzo, just around, there's a slight distinction between safety because you understand the detailed inner workings of something, and safety as in, does it actually, can you deliver the process and output you want in a way that does not, let's say, damage a human being or a product, right? And so maybe what I'd ask you is it that, I don't know, I mean, I learned to code when the days when you'd had machine language, you'd have literally machine code at the beginning. Most people don't understand machine code anymore, right? It's abstracted, but it doesn't mean there isn't higher order thinking about a process or how you put things together. So I suppose my question is, will we develop, still using our higher order thinking skills, maybe around the process of building, I don't know, maybe mechanical engineering, but do you really need to understand what's inside that, an LLM, for example, to actually do that?
No, but I need to understand how it reasons. I mean, prompt engineering right now, there are books that came out like mushrooms. This is important because it makes you understand the logic and the question that you are giving to the machine. So you can expect or predict an output, but it's not something that is completely unexpected.
No, but that's what I'm saying. Maybe the training is in logic and process engineering as opposed to not necessarily purely coding, let's say.
No, for sure, yeah.
Can we stay with that for 1 second? How is AI changing the way engineers are qualified, taught and qualified? You use the example, ChatGPT gives you a mechanical engineering degree. Don't want to drive the car that you've just designed, though. So how is it influencing how kids today go through college? How they're educated?
I reply.
Well,
I mean, I was a bit in neuroscience in the past. I was a slave of neuroscience because I'm an engineer. Neuroscientists are, a level up, and they say, well, I need a robot that does these things. So, but what I learned from them, brain is a greedy optimizer. This means that if you can save energy, it saves energy. So, I mean, if we just don't go into engineering, but essay composition, you know that if you have large language model, ChatGPT, you just have an essay. But the process of the deduction process right now is completely erased, partly. There are people that are by far much more, let's say, responsible. Eventually, an engineer and says, okay, let me use this, design system in order to understand if there are different solutions beyond eventually the one solution that I have achieved, and then gives you the capacity of understanding if there are solutions that are better than yours. So discrimination of the solution that is provided by large language model or any kind of AI system that provides multiple output and has a velocity of access that is unreachable, that one is probably, at least this is the way I use it.
Can I follow up? Someone else wanted to?
Yeah.
Sorry, Corina.
Yeah,
Go ahead.
let me think of the life of an engineer in automotive industry and start with the life of an AI engineer. So we really have AI engineers at Continental in automotive industry. So one of the major things which you had to learn is how is a car driving. So to learn more about the physics in order to develop AI algorithms in order to somehow master this physics. So one way of change, or one change, was for us as computer scientists to learn more about physics and how a car, an engine is working. The second change is in the life of the car engineers. So we have colleagues who incrementally learn more and more about AI, about control theory. You maybe notice MATLAB Simulink tools coming with toolboxes for machine learning, and it was a kind of natural progress to use more technology in order to do better solutions. Then think about a software engineer, the life of a software engineer. Of course, with GitHub Copilot, these kind of solutions, they evolve more and more in software architects and let the puzzle pieces somehow being generated by AI. So the change in the life of an engineer is very diverse, and we have to enable this kind of journeys and involvement from car engineer towards an automotive AI engineer and so on. So
I had a very similar comment, as I can follow up nicely. So my idea was like, if you have a calculator, you're either the user, you just put numbers in and get numbers out, and probably if they're wrong, you don't even know. And then there is who develops the calculator, and they need to know what's inside, and somehow they need to certify that it works properly. So it's very similar with neural networks, and it's like a connection with my previous point. If you look at it as a black box, and I imagine most of the people look at them as a black box because they put text in, prompt in, as you were saying, and you get like images and videos out. Amazing these days. But the thing is that if you develop the safety layers, as we were saying before, if you develop the technology, if you want to understand and certify the technology itself, then you need to look inside. It's not for everyone to do it. It's not for every company around here to do it. But there will be, and we need to have people with the right skills, the right understanding of robotics, of physics, as you were saying, Corina, to be able to look inside and certify and give like us an understanding of what is doing and why is it doing it, and if it is certifiable or not.
Go back to education for a second, because you were asking about education. So I'm an Imperial College alum and a chair there, and Imperial College has just created 4 schools of convergence, because what that means is they've basically taken the different faculties. So there's a new school of artificial and human intelligence combined. And the faculties that are pulling together in there is computer science, which includes obviously AI as well, but it's also neuroscience, biology, psychopharmacology, robotics, because what they're really looking at is how the change of intelligence is going to happen artificially, whether it's in robotics, is also going to change human being, potentially. And actually, you need a hybrid thinking of education to actually solve the future problems. So if I said to you, your children, and I do say to my children, I've got a 17 and 20-year-old, I've got one who's doing industrial design, so very much more engineering and design, and my daughter wants to do neuroscience. She's flipped to the other side of it, where she's really thinking about how to apply this into society, right? They need the hybrid thinking. That's what we've always said to them is don't get fixed on, one class of subject only, because you're going to need flexibility and adaptation, actually more than anything else, to solve problems going forward.
Last question that I want to ask about is, what's the difference geographically in the adoption rates of what we're talking about here? Here you've got a lot of fear in Germany that we're getting left behind, that China is moving ahead. We had a little bit of that in the side comments here, that we're inventing regulation, they're inventing industries. What's your take on that as to where we are in Germany and Europe compared to the rest of the world, and what should happen?
At the educational point of view, I can reply. We know that China is going fast in that direction, including since very early stage in the school, the use of AI instruments. And to be honest, we said before, they dare, they win. So there's a military phrase, who dares wins. I mean, these are the British. But to be honest, they are daring, and right now, honestly, they're winning. So how the learning paradigm will be changed or shifted using artificial intelligence at the level of early school academics, we wonder if it is a risk. They assume it is a risk, but they also want to be the first in case it's not a risk, but it's a step forward. It's, they're taking the risk. So, and I agree with them, Mark, if you want to see that.
So I can't comment on the AI portion, but on the robotics portion, there's two interesting things happening. On the one hand, the fictional narrative about robots like ours is very dark in Europe and very dark in the United States. I can tell you every meeting I've ever had over the last 5 years at Boston Dynamics, somebody brings up Terminator or Black Mirror. So I think so there's a general fear for autonomous mobile robots, I think, in those countries. That's not true in Asia. And then secondarily, within my two robots, the truck unloading robot that we sell very well in Germany, maybe because it's confined to a container and it does its job and it's very confined. Versus the spot robot that you saw earlier, we have almost no traction in Germany because people are deciding to wait. They're like, that's too early for me, I don't want to do it. The regulation is not there, the certifications are not there because they're outdated. And so I fear for Germany in that if we take a wait-and-see approach as a country, that will not end well, I think.
So from me, you'll get a very biased answer, right? Because I'm a born native Romanian working for a German company or a company which is multinational but headquartered in Germany. And this is the perspective from which I will give an answer to the question. Yes, there are differences. In China, very fast in adoption in mass adoption. Once you arrive at the airport in Shanghai, AI is everywhere. Yeah. Everywhere. You can, not so much talking about AI, but a lot of solutions, apps, and so on. In US, very innovative business models, entrepreneurial mindset, the willingness to bring solutions fast on the market, to have this validation fast from the market. But I'm a strong believer in the European way and the power of purpose, the willingness to take everybody on this journey of progress and have a kind of equality in the society. And I am also convinced that everybody can play a role in shaping the future, but you have to do it. Yeah, you have to start with that. Right. And don't take so much time to think about yes or not. The only loss which you can have with AI is to not start today. Yeah.
I think I want to agree with Corina. I used to live in Italy, then I moved to UK, and now I live a lot somehow in the California time zone because we work a lot with the Mountain View team. And I agree with what you said. I see, in particular in California, this need to jump on the thing and then immediately hit the ground running, and then being able to deploy a technology quickly before it's too late, which honestly I didn't feel when I was in Europe, in the Europe time zone. It's like it's a different mentality. It's a bit less risk adverse. It's actually quite happy to take a lot of risks earlier in order not to lose the first mover advantage. So I think there is that element that somehow can be improved. It has nothing to do with how we do things. It's just how we get rid of the fear of failing and just hope that good things will happen rather than the bad things.
But I think one point, we have so many success stories we can learn of AlphaGo, Google, everything. So take these success stories as inspiration and do it our way, create our next success stories. So just waiting, just criticizing, just analyzing the status quo, this won't bring us to a role in this area of AI and robotics as Europe, as Germany. Yeah.
And if I can add up on the problem of dual use, of using AI and robotics also for, let's say, security defense. I'm convincing TU, I'm in opening robotics and AI for defense and security research line inside the Munich Institute of Robotics and Machine Intelligence. This is my initiative. I would assume the responsibility. But I think that many of the applications that we have at MIRMI are also in security, and as well as many applications in defense and security, then they have their own roots and they go directly to civil application. And this is, and it's more like, let's say, a duty also for the university.
Just a final thought to sum up the global situation. We're in a non-linear step change right now of technology and application. Yeah, it's not like it used to be. You can't hang around and be a laggard waiting for it to happen. Yeah, because it's runaway competition right now, globally, and it's global. So China is leading right now, then the US, then Europe is lagging. And I say this as a European, or I was a European until we sadly Brexited, but we really actually do, you need to take it very seriously right now. Yeah, this is going to shift very, very quickly. So if you have a doubt, take a chance and a risk. Yeah, there's a lot of people here that want to help you do that, but do it, because it's going to be too late actually, otherwise, I would say. Yeah. So just a...
Okay, that's a perfect wrap up to what we've talked about. So the biggest risk is not to take the risk and not to take it now, to wait around and see what happens, and that's none of us can afford to do that. Thank you to all of you for a fascinating discussion. We could talk for another hour, and I'd still only get through half my questions, but we'll come back in at the next Automatica and unload the rest of the questions. Thank you very much.
And I'm doing a little talk in a minute if you want to stay and hear more. So,
and Wendy is talking here on the stage and is going to show some developments right after this.
Thanks. Thank you very much.
Thank you.
Ken, thank you, as always. Yeah.